Limits using graphs and tables are really easy to visualize. After all, that's what graphs are for. So how do you find a limit that you can't really visualize? In this video, we're going to evaluate the limit of functions without a graph or table. So let's get right into it. When all we have is a limit, the first step is direct substitution into the function. The output will tell us about the limit. If the result of the direct substitution is a real number, then that's the limit. If it is a number over 0, then the limit either does not exist or is unbounded. And if the result is the indeterminate form 0 over 0, that tells us that we can try to manipulate the equation and hopefully find the limit. Let's see what all this means. First, let's find the limit of x plus 3 as x approaches 0. Well, directly substituting 0 into x plus 3, we get 0 plus 3, which is 3. 3 is a real number, so that's our limit. To verify our answer, let's take a look at the graph of x plus 3. As x approaches 0, we see that the function indeed approaches 3, so 3 is the limit. Here's another one. We're trying to find the limit of 1 over x minus 1 as x approaches 1. To find this, we begin by directly substituting into the function. In the denominator, we have 1 minus 1, which is 0. This leaves us with 1 over 0, so we know that either the limit doesn't exist or it's unbounded. And looking at the graph of 1 over x minus 1, we see that as x approaches 1, the limit does not exist. Alright, what is the limit of x squared minus 9 over x plus 3? Well, if we directly substitute, we get 0 over 0. So let's try some algebraic manipulation. We know that x squared minus 9 is a perfect square, so it can be factored as x plus 3 times x minus 3. If we use this, now we see that the x plus 3's in the numerator and in the denominator cancel out, leaving us with x minus 3. If we directly substitute in now, we get negative 3 minus 3, which is negative 6. Negative 6 is a real number, so that's our limit. Again, we can look at the graph to confirm our answer. Here's another example that has a radical. If we directly substitute, we get 0 over 0. So let's try to manipulate this problem. Since we have a radical, let's get rid of it by multiplying it by the conjugate. Simplifying the numerator, we get x minus 4 minus 1, which is x minus 5. So the x minus 5's can cancel out. After doing this, we get 1 over the square root of x minus 4 plus 1. And now we can directly substitute in again. This time, we get 1 over 1 plus 1, which is 1 over 2. And that's a real number, so that's the limit. Once again, we can check the graph and we see that we are correct. So now, you know how to solve a limit without a graph or table. Direct substitution is the key. If you enjoyed this video or learned something, don't forget to leave a like, subscribe, and share it with a friend. Now, keep working hard and keep learning. Thank you for watching.